Hello everyone. We are now learning the content of the decoder and diagnostic interface cannot communicate with the diagnosis. A chain EV per electric car, the customer response remote key cannot unlock the vehicle. Use the mechanical key to unlock. Step on the brake pedal. Press the start-stop switch. Instrument black screen, no display. The speaker can work normally. Through the diagnostic instrument connection, found that the diagnostic instrument and vehicle, all modules cannot communicate. Can you use the diagnostic instrument to diagnose the fault of the whole vehicle? Module cannot communicate. We have 10 learning task objectives for this course. 1. Know the meaning of each pin of the diagnostic interface. 2. Knowledge of diagnostic interface troubleshooting methods. 3. Ability to correctly recognize the decoder and diagnostic interface. 4. Can read data streams and fault codes correctly. 5. Ability to use meters to correctly measure diagnostic interfaces. 6. Be able to independently complete the diagnosis and troubleshooting work of the decoder and diagnostic instrument interface cannot communicate. 7. Serious and rigorous, proactive, safe production and civilized const. 8. Ability to cooperate and coordinate work with team members and classmates. 9. Gain a basic approach to analyzing and solving problems. 10. Proactively communicate and discuss learning outcomes with group members to complement each other's strengths and weaknesses to accomplish self-improvement. 2. Safety requirements and precautions for task implementation. 1. Before the start of the practical training, prepare and advance the personal protective equipment to be used and check that it meets the criteria for use. 2. Before the start of training, do a good job in advance to protect the site. Set up warning signs. The operating position of the arrangement of good insulation protection measures. 3. In the process of practical training, it is strictly prohibited to play around and do a good job of recording data and results. 4. At the end of practical training, the site and equipment must be cleared and warning signs removed. In this class, we will learn today's content through 4 parts: phenomenon analysis, troubleshooting, and on-site 6 is organization. During the implementation of the task, we have to pay attention to and do the following locations. Part 1. Failure phenomenon analysis. 1. Start the vehicle. Found that the instrument does not have any display. The first reaction for the whole car without electricity. By pressing the horn to identify the sound loudness can be initially judged whether the low voltage battery voltage is normal. You can first check the front compartment, low voltage wiring harness and battery voltage. 2. In line with the principle of the troubleshooting process from simple to difficult, first use the diagnostic instrument for diagnosis. Found that the diagnostic instrument and the whole vehicle module cannot communicate. 3. The main reasons why the diagnostic instrument and the whole car module cannot communicate. Diagnostic instrument failure, DLC interface failure, low voltage battery loss, and so on. Part 2. To troubleshoot. Step 1. Check the low voltage battery voltage. Low voltage battery power loss can cause the whole vehicle without power, that is, the vehicle cannot be unlocked. Diagnostic equipment in the vehicle cannot be communicated, and so on. Normal. Step 2. Applied the brakes and switched on the ignition, and found that the gauges did not come on. Step 3. Connect the VCI and plug the OBDII diagnostic connector into the diagnostic interface. Step 4. Select the model. Perform a full module scan and find no faults, as shown in the figure. Step 5. The diagnostic instrument VCI power lamp does not light. Query the electrical schematic diagram 1 to 2-6. Measure the diagnostic port GO316 and GND voltage is 0 volts. The standard value is 12 volts. Step 6. Turn off the ignition switch. Disconnect the negative terminal of the battery. Use a multimeter to measure the resistance value between GO312 and 13. The standard value is 60 ohms. Step 7. Install the negative terminal of the battery. Measure the voltage at the upper and lower ends of the safety inserts. The upper end of the measurement of power. The lower end of the measurement of no power. The standard value of December 13 volts. Part 3. Failure recovery. Failure recovery. Replaced F to -45 fuse insert. Troubleshooting. Full module scan. Part 4. On-site 6's organization. Workstation 6's. 1. Collate to and not to. 1 to stay and 1 to discard. 2. Reorganize scientific layout. Quick access. 3. Attainment form a system. Develop habits. 4. Surety the alarm bells are ringing. 5. Sweep clean up the garbage and beautify the environment. 6. Economize economy is proud. Waste is ashamed. The main goal of this course is to recognize the basics of new energy vehicle troubleshooting. Master the decoder and diagnostic interface cannot communicate with the diagnosis and troubleshooting. I hope that you can review and consolidate their own after the class. This class ends here. Thank you.